All right, we'll get started now. So, good morning, everyone who showed up today. Thank you for being here, as always. Welcome to tutorial 6. I want to ask, how did the lab assignment go? Yeah, it was straightforward. Did it make sense? Yeah. Can't wait to see those submissions. In fact, I'm gonna quickly go through some of them just for fun, just to see how things are looking. So this is the part 1 for the arm rig, and this was very simply just touching on everything that we did in class, in the lab classes so far, right? And so I didn't want you to have to make the rig or the actual bones, so I provide that. But everything else, all the steps to get this rig kind of working, like the our correction keys, weight paints, and proper constraints and everything. And so, oh wow. Rotation, beautiful. Copy rotation, yeah, that's beautiful, beautiful. Nice. Weight paints look nice and smooth on so many of these. And then the correction keys, the bicep is really prominent. The shape key here, beautiful, beautiful. Copy transforms, that's good too. The thing is, for this specific rig, we kind of did a FK setup, at least for this one. And so you don't really need copy transforms, you only need copy rotation, just because you're only ever going to be rotating FK bones. And so it's just a bit of a waste of transform data to have the copy transforms, which includes the scaling and location, as well as you could accidentally get unwanted movements because these constrain also to location and scale, right? So if you accidentally move one of these bones, if you had copy transforms on, it would move the bone, and that's probably not ideal for this setup. But for the most part, that's pretty solid. So here, copy transform, copy rotation. Excellent. Let's see this corrective shape key. Nice. Elbow's looking good. Biceps looking good. Yeah, so I'm happy about all these. What I'm seeing, makes me very happy to see. So that's good. Can't wait to mark all these and look through them. And so, on that note, back to what we're doing today. So far we've covered the basics for rigging in week 1, and then week 2 was about constraints. Week 3 was drivers. Week 4 was weight painting, and then week 5 was that assignment. Now for week 6, we're going to start with working on things related to the entire full body of the rig. And this is probably where this will be most relevant to your assignments, to your school projects, and applying this to your games and your characters. Though this might be a little late compared to where you are in your character rigging process. You might already have the full deformation character rig finished, but this is important to cover nonetheless. Just make sure, okay? Yeah, so first of all, reminder, lab assignment 2 is in 2 weeks. So no need to fret. This is sort of a part 2 to the arm rig assignment, where what we learn in these next 2 weeks will apply to that assignment. And it was unfortunate, just the timing of reading week made it so that these three assignments are a little more uh, constricted to each other, mainly because these labs are a week after the, like they're following the actual lecture for that week by a week, so it's a little harder to keep everything dispersed because of that. And so for that, as I said, we'll expand on what we made. And so you'll see throughout these next two labs that we'll cover some important topics for rigging. Hint, there's going to be some IK constraints we're going to be making and some IK controls. So just keep that in mind. Stay tuned. All right, today's plan is a body deformation rig. So you all know what this is, of course, specifically for, at least right now, the face rig. And now that we're moving away from making a face rig, we are going to head into making a full body character rig for this course. And so today's plan is to build a body deformation skeleton. So I'll be showing you the whole process to my knowledge, including the breakdown of the hierarchy and naming conventions. And then after that, we will create a intermediate skeleton. So this is another concept that is helpful to know, especially when you're in the industry. It's a way to organize your bones and separate your interaction to the deformation bones, because when we are making these rigs, ideally we want to be interacting with the deformation bones as little as possible so that we avoid any headaches and broken rigs later on. And so this intermediate skeleton, we can quickly rename all of the def prefixes, and then we can understand why exactly we're doing this for our game engines. And then finally, I have a simple script to showcase that I'll provide to you as well to showcase the power of scripting in Blender rigging. And this will help us to quickly constrain all of the intermediate bones to the deformation bones. And I'll showcase that when we get there. So, the body rig, our base for character rigging. So, for your games, you need to take your character, which is standing still and static, and then give them a skeleton so they can move and they can have poses, right? Without the skeleton, you can't do this image on the right. You can only have a static image on the left. And so, first of all, I'm going to kind of do something a little different. I'm going to go through the slides. How's it going? I'm going to go through these slides as I'm kind of working in my Blender project. And so, starting things off, I have open here a Blender scene with the Hippodrome model. No rig or anything yet. And so that's what we're going to be doing. We're going to be creating the deformation rig in this class time. So, or at least I'm going to be showing you how to do that. So, first thing, I'm going to Shift A and then create armature, right? So, this is always the start of our body rigs, and it is important that you have this root bone. So first of all, you click Tab to go into edit mode, and then we're going to be sort of shifting this. What I like to do is I like to change my transform pivot point from median to active element, so that way it rotates around the head of the bone, not the tail, right? And actually, a little word of advice, just in general, because we're going to kind of see this throughout this process today. This bone display, this octahedral bone display with a tail, what really matters is this head bone and the direction that this tailbone is facing. If anything, the length of it isn't as important because our games or our rigs will only care about the rotation, at least for the most part, of this. Our deformations will only care about this part of our bone, right? And for, let's say you're using constraints, then sure, the tailbone could also be an important area to place properly. But for deformation purposes, it's not as important. What's more important is the rotation of this bone. And so for this root bone, we're going to be clicking R, X, 90, negative, at least in my case here. The main thing is you want the head of this bone or the tail of this bone to be facing along Y, right? So you can see in the top right over here, the little gizmo, there is the Y, positive Y, and then negative Y. This bone needs to face, you can see even if I click G, I change my transform orientation to local, GY, positive, moves along that axis. That's just common practice for these in general. And because the bone, this is also the bone's Y direction, so it just keeps it consistent with the world space, right? And so naming, specifically for Unreal Engine, the armature name must be kept as armature in order to determine its root bone properly. However, it's still good to follow this naming scheme in Unity as well, just for cohesion across the different engines. And beyond that, we keep naming as we know how to, right? And so we'll just leave this first bone as root, right? So this one doesn't need to be called def or anything, right? So a root bone can be used in the game engine for things like ground detection, animation, base movement, and it serves as a marker for the character in the world, and it's the top of the hierarchy. And so within a deformation skeleton, we have, different parts of the body. These 5 that I'm going to mention is the spine and torso, the legs, the arms, the neck and head, and the twist bones. And it's really important to know how you're going to be building out your deformation rig in a very hierarchy-based approach, right? I'll just stay here for now. So what I'm going to do is I'm going to X-ray wireframe. You see? So up here, I just turned it to wireframe in X-ray mode, so I can see where I'm placing the bones. And so first thing, I'm going to take this bone right here, or actually just because I want it to be facing its default orientation, I'm just going to click Shift A while in edit mode of the armature to place a new one. I'm going to place that around the center of our hip here. Call this def underscore, this would be hip, if I'm not mistaken. And so from here, just gonna move this down a little bit. And ideally, there are those different rigs you see where they might have sort of a curve in the back like this, and that's fine. But when we're making a simple character rig for our games, we want it to be as simple as possible. Specifically on the orientations of the bone matter so much when you're trying to make things less of a headache, that you probably want to keep the bones as straight as possible when you can, right? And so for something like the chest bone, it could make sense to kind of have it rotated backwards a little bit like this. And then throughout this chain here, I'm going to be, remember, there's no perfect way to do all this, but it's good just to follow a consistent regimen for when you're making your rigs. So you can see here, if I go to bone hierarchy, what's important is naming things in a way that works best for you, most consistent for you. In this case here, the deaf pelvis is what that first bone was called. And I could certainly rename this to deaf pelvis if I wanted to. It's really up to you how you want to keep things organized on your end. But I'm going to go through, and what I'm going to do is instead of having the, let's say, spine.001, I'm just going to do spine A. And I'm using camel case. So camel case is when the first letter of the word or the name is lowercase, and then the second sort of word is uppercase. So it's because it looks like a hump, like a camel hump. So if I make a new bone, if I type in camel case, you see this little hump. Right, and so at this point, you'll notice if I go in pose mode, if I do RY, just very clean rotations along that spine axis, so that if it's rotated like this and you start to rotate it, the rib cage would kind of move or rotate in a very upward facing direction. Ideally, you do not want that. Though it seems for the chest, at least, you do kind of have to move it back a little bit so that you can have the spine or the neck bone in the right spot. And so I'm going to go down this chain. I'm just going to rename spine B. And then chest. Make sure I'm going to be in edit mode when I'm transforming these. I'm just going to clear transform in case. Yeah, in edit mode. GZ. You kind of have to imagine where your pelvis bones will be starting out, right? Like, where is that point of rotation in your body? Right, it's a bit hard to determine, so I'm just eyeballing it for now. Right. Let's go back. Orientation. Okay. And you see how everything is sort of in a hierarchy-based approach, so that you don't have to worry about moving each individual bone separately, because by default our bodies work in a forward kinematics way. That's just how the bone structure works. And so you don't have to worry through doing this approach as much. From this point, I'm going to Shift D to create a shoulder bone. Actually, I'm not, because this one's rotated. I don't want to use that one. I'm going to Shift right click and Shift A. Let's create a new bone entirely. Call this one def underscore shoulder. And then I'm going to do underscore, let's see. Now I'll do dot L. So it's the left side. Right? And so if I rotate this 90, scale it down a bit, so to position that inside GY for me. And you see how instead, a lot of the time you might see a clavicle bone like this, where it's sort of near the front. But you gotta imagine that when you're making a deform rig optimized, it doesn't have to be perfectly anatomically correct. It has to just rotate in the same way that your body does. And so your shoulder doesn't really, like when you move it up, when you shrug it, it just moves in a linear direction upwards. And if you move it forwards and back, it's also that linear direction. And it's sort of, you can imagine it's sort of orienting around a point around here, right? So not exactly at the symmetry line, but sort of out a little bit, right? And sort of in the middle too. Just because also when you have your deformation rig really close to the actual spine, it really kind of distorts the rotation or the deformation of the actual mesh itself. Your spine doesn't just, it has several bones in it versus 4 here. So when you rotate it, it's doing more than just rotating. It's also changing its length and everything. And so if you rotate, let's say this bone along that curve, sure, this part of the mesh will follow suit pretty well. But then this part of the mesh has a much larger curve because it's further away. And so you can easily see that this part of the mesh will really clip inside of the chest or of the body really easily. So it's not too ideal. Right? Actually, I'm going to keep the chest bone sort of just straight up. Because you do not need to connect every single bone to its tailbone. Remember, as I said, the tailbone is just more of a visual thing unless you're using constraints specifically. Right, so the neck can be separate like this. Right, this just enables your rotations of the chest to stay in a very linear planar direction versus if it was sort of facing backwards a bit, your movement would be moving up, your arms are moving up a little bit as they move forward. So this just keeps the arm moving in this direction versus a direction like this, right? However, for the neck does have a little bit of a forward sort of bone path. And we could do 2 neck bones like this, right? Kind of behind the ear. And then the first one is around where the chin is. And the root is here, right? It takes trial and error to figure out exactly where you want them. But rule of thumb is follow the rotation of whatever part of the body you're placing these at, and try to keep them close to the center of the mass, right? And then from here, I'll just scale up the head bone. And if you're trying to connect this to your face rig, you would probably not use, you would not use a new head bone. You would just do your best to attach this part of the neck to that head bone itself. But in this case, I'm just making a new rig, so you can just do this. Right? And so something like this head bone, I want to make sure it's straight up to make it easiest to deal with later when you're actually animating or you're constraining and then posing. Right, before I continue, very important, I'm going to rename these new bones I've created. So that there's a chest 001. And oh, you see here actually for some reason when I was making this, both the neck and the chest are on the same hierarchy level, so I can't rotate the neck with the chest, and same as the shoulder is not attached to the chest. So what I gotta do, select, and then select the chest, Control P, keep offset. Now if I try to pose it, you can see everything follows, and then these bones go down the line. Right? And so in here, I'm going to rename this to neck A. Oh. And I will show you later why I'm using letters instead of numbers to label the variants of the same bone name. And then def head. Oh, no capital there. Right. And so def shoulder L, and then at this point, I'm gonna create a new bone. I'm just gonna duplicate this one, and then shift select the shoulder bone, Control P, keep offset. Right, so now it's a child of the shoulder bone. So at this point, I'm going to roughly place this bone in a spot that will reduce the chances of pain and frustration later. A good rule of thumb is there is like you can see the curvature right here of the, here we go. Around the halfway point along a curve or along a line that follows that shoulder bone down and then straight to the side. you're kind of following this sort of part of the arm here, or the shoulder here. It's hard for me to explain exactly, but around here is where you would want that shoulder bone. Right? And also it's trial and error too, so it's never perfect right off the bat. But what's important and what you can control right away is the rotation or the orientation of the bone as you're placing them, right? So I could certainly move this bone like this and then this one like this, but that is not ideal. In fact, that's not what you want to do. You want to make sure your arm is very straight and sort of in the middle. But at the elbow, you can give that a little bit of a backwards. Doesn't have to be that much, but just a little bit backwards. Why? Because when you're making your pull vector for your IK in the future, the elbow, it will know which part. So because now we've created that offshoot, that slight deviation, this is the angle that the pull vector will gravitate towards at first, right? And so, yeah, adding that little bit of a bend towards the end of the edge of the shoulder this way. Now our little pull vector here will know, or our arm here will know that this is the direction to face, right? And so now I'm going to start creating the fingers. Before that, I want to rename once again. Def upper arm. From this point, I can create that wrist bone, and this wrist bone can be straight. So it doesn't matter if it's sort of in the middle of the actual wrist, because we're imagining this, in this case, we're just thinking about the rotation, or the orientation of this head bone here. And so our wrists are always going to naturally want to rotate exactly like that. So in doing so, that just makes it easier later on when we're doing our rigging and animations, right? And so from this point, I'm going to rename that def wrist. And then once again, I'm going to select that tailbone and then click D or E to extrude along X. And when I extrude from that tip, actually wait, no, sorry. I do not want it to be attached like that. So I'm just going to duplicate this bone and then shift select, Control P, make parent, keep offset. Right now it's parent object or a child object. of the wrist. From here, I know the naming can be tedious, but naming is very important for rigging. Let's just call this pinky, pinky A dot L. So put that in. E to extrude, E to extrude. Right? And if we do, so in a perfect world, our model will look like this, where our fingers are straight ahead, not out, kind of like this. So when our fingers are like, oh, hello. When our fingers are out like this, it's more annoying because our bone orientation will now not be along a global 90-degree axis. The thumb is always inevitable, but that's the thumb, it's fine. But we can control if we make our actual meshes properly, or in this way, we can avoid having to do these fingers in different orientations. All right, so I'm just gonna go down the chain, and I do tilde and then show active to just quickly find that bone I'm selecting. Pinky B, and pinky C. So it's always going to be A, B, C in this case. So the lower alphabet is, or letter is going to be further down the chain, right? And so you can see on the side view, it's actually really low. So we just gotta move that up a bit. Z. And it's always good to snap on the axis. And if anything, in this case, we can kind of have the fingers a little closer to the top, because when you actually bend your finger, you can notice that all that skin bunches up in front of your fingers because the bone is closer to the top of your hand, right? So right when you bend your finger, great, right, that skin will sort of fold over itself a little bit. So that means it's okay for us to place the bones a little higher, right? And then making sure we're placing those bones on the knuckle. Ideally between our loop cuts, our actual loop cuts. And then if you look at your hand, you can see, okay, that pivot point is going to be right on that knuckle, pretty much. So I'm just going to follow suit. See? Boom, boom, boom. Duplicate. And I feel like keeping all these bones on the same plane as well. Just actually no, we can just move. Oh, we can move these up a little bit. And I won't rename yet. I'll rename in a second. I just want to finish these up. You see these fingers are naturally, the bottom of them are naturally longer. You can see. And it is a bit annoying how there is this noticeable angle of the fingers compared to the bones I'm placing, but it's just best practice. If you have your rig closest to your fingers facing forwards, placing your bones like this, right? And so now, before anything else, I'm gonna go through and I'm gonna do some batch renaming. Oh, it's not here. It's gonna be later on, but I don't want to spoil it. But for now, I'm just going to do function F2, or sorry, control function F2. Make sure batch rename is set to bones. So it says rename 3 edit bones. Those are the ones I'm selecting. Find pinky. Replace pinky with, let's say, ring. Pinky with ring. See? And so I'm going to also, because we set them A, B, C, the numbers are all the same, and that's really important. That makes it much easier later on to deal with batch renaming. So once again, Control F2. Anything with .001, replace it with nothing. And this kind of shows that at some point, if you're doing a lot of rigs that have similar naming and consistent conventions, then making a script to do this automatically, like renaming and placing even, that's when it becomes powerful. And so later on in this course, I'm going to have a class just dedicated to trying to create a little script. Nothing crazy, but I do have an example to show today to help with this process that we're doing right now. And so from this point, I'm going to select the middle finger. Find pinky, replace it with middle. And you don't need to have long names, middle finger or ring finger. As long as it's nice and concise, but it's differentiated, then that's important. That's really important. And also, we can find anything with .002, replace it with nothing. Okay. And then def pinky, once again here, pinky with, say, index. And then find .003, replace it with nothing. See? That's all the renaming, but it's good to do it. And so, actually, before we make the thumb, I want to create a little this bone here is specifically to help with when you're making a fist, it brings that pinky area in more. you can control that so that the pinky moves in more as you make a fist, so that it's not looking like a block, because that doesn't look real, and your hand doesn't work like that. You have these, I believe they're the metacarpals here, 4 of them. So you could place 4 of these, though it's not necessary as much. In this case, I just want to show an example of 1 for the pinky area, because that's where you see it most on your hand when you make a fist, where it sort of moves down the most. So I'm just going to call this, actually before that I'm going to make sure it's parented to the wrist first. So Control P, that's it. So now in this hierarchy, there's the pinky fingers and then this one here. I'm going to call this, let's see, pinky replaced with pinky. Let's call it fist fix. Or first, not fist fix. Not the best naming, but make sure that's selected to bones. Oh wait, I was battery naming when I was hovering over this. Let me just hover over the scene. There we go. Pinky with fist fix. It's not the best name for it, but I'll just call it that. There. And this one can be rotated because it's not as important to worry about. Like, it actually has to follow that part of the hand to do that deformation properly. And then now we're going to make the thumb. So I'm just going to duplicate that finger. And ideally we also kind of want, oh, this is going to be a little more difficult. But we can, because I have it on local, I can just RY. Oop. Sorry, not RY. Or is it RY? It should be. No, wait. We can set this to normal. Normal is my favorite transform orientation to use because it's based exactly on that component you're selecting. So now RY will, well, it should rotate it along its normal here. Interesting. That will be something we have to control later with rolls, unfortunately. Don't know why it's doing that, but that's fine. I actually placed that pretty well right off the bat, but you see we're kind of doing the same thing up here, just at the thumb in this arbitrary angle. And I'm trying to keep it straight as possible. And this goes to show when you have good topology, and not just topology, but good form on your model, it's easier to rig it later and animate it. Placing the bones is so easy like this. Because I don't like the orientation right now, I'm just going to skip ahead a step for a second and then go to click N to my item transform tab here, roll. I'm going to hold Alt and then roll, because when you hold Alt, it affects everything you're selecting, not just the, if I'm not selecting or holding Alt, it just rotates the selected component. But then if I do it all, you can see it does everything. Also, we don't know which orientation to put this because we don't see an axis. So as we've learned before, if we go to our armature we can turn on our axis like this. So that makes it much easier to tell which way we want our thumbs to go. And this is a bit of a tangent ahead of what we're supposed to be doing right now, or what I'm wanting to show right now. But we're going to make sure, at least a good practice is to make sure that the positive x value is in a curling or sort of closing direction of your body. So you want to make sure positive x is when your arm is closing like this. So if I show it here, positive x is flexing, and then negative x is relaxing, right? So that's not just for your arms or your fingers, where this is positive x, this is negative x direction. It's also for your body as well, your spine, your chest. If you move forwards, we can assume that is flexing, and so positive x would be moving forward. Positive x would be moving our head forward. Anything that's sort of kind of bringing you closer or bringing body parts closer is a flex, right? And the opposite is extending, right? And so if we turn on individual origins, then Rx, oh, not edit mode and pose mode, Rx. If we rotate along, you see the top, we see our rotation is positive along normal x. That is the opposite way. We don't want our thumb to bend that way. So edit mode, we're just going to set our x values like so. And ideally that z direction is the direction your bone will rotate towards, right? So I'm gonna set that to 90. It's close, negative 90. It's close enough to 90, so I'm just gonna snap it to that. And remember, the roll orientation doesn't, you can go to 360 and it's, or even 720 if you can do that. It's actually the same value, but it's better to keep these values closest to 0 as possible to avoid any sort of large numbers causing problems. And so now if I select these bones, see that's beautiful, right? So that's the direction ideally our thumb will bend towards. Not perfect, but it's sort of trading off the direction of flow of our thumb here. Ideally, our thumb might bend more. I'll do that. Just place a new note. A thumb would ideally bend more that way, but this is fine. Right? And so at this point, gotta do the rest of the feet here. I'm just going to shift S, cursor to selection, and make sure it's on active element so it goes to the, I'll just select the root there, create new bone. Wait, actually, did I miss something? Did I do something, or did I miss a step before going on to this part of the bone? Did I miss something at the hand before I continued onwards? No, not the parenting. It was related to the thumb. I haven't named it properly yet. It's still index. So what I gotta do is I gotta go in here. And I gotta set index to thumb. See? Actually, I gotta do it in this hierarchy right here. So index to thumb. Then replace .001 with nothing. Right, so it's looking very pretty. I like how this looks. Super clean, super readable. And now I can work on this leg here. Rotate this. And we can use that tail as a reference as which direction we need to orient this in. Because ideally our flow of bones should follow that Y axis. So R180. Oh, let's make sure it's snapping along. Oh, there we go. So straight down. Once again, we are following that curve of our body, those natural curves. So it's going to be around the middle. Right here is where we place that part of our thigh bone. Right, and from here move it down, straight down, and then this is the part where we actually want to make sure that it's rotated or that it's oriented toward, like, on an angle like this, because our legs very prominently follow this sort of backwards shin direction, right? Down to the ankle. And we can put these around the center. I'm making sure that this thigh bone is straight down, directly straight down, but then this shin bone can be a little different, be a little more hand placed. Let's see. So I'm just going to call this, first of all, I'm going to make sure this is parented to this pelvis bone. And I mean, I'm sure you've seen those pelvis bones like this, right? And for this rig specifically, I'm just not going to do that, just not because it's not needed, but to keep it as simple as possible for the demonstration. And so yeah, if I close all that, you can see the spine. So the pelvis has the spine, and then the legs are going to be those only two bones that are parented to this pelvis. So I'm going to call this def underscore upper leg or thigh or whatever you want to call it. Let's go with that. Dot L. Def lower leg. This also keeps the naming consistent with the arm. So both upper, lower. Just helps also when you're trying to find certain areas. Not needed, but it just makes sense for me in this case. And from here, this is an important one. This is helpful. So usually you'd see your feet bones like this, where you're sort of following this tailbone exactly across, like along your rig, and then you want to have it like this. You want to bring it all the way on an angle down to your toes. This is not ideal, really, because it creates a very annoying angle. Did it not draw? Hello? Oh, it's 3D cursor, that's why. Here. Hello? Oh, there we go. Oh dear. There we go. Okay. Sorry. It will rotate along this angle. That's not fun. That's annoying. That doesn't look right. That's annoying to work around. You're going to be fighting against the natural rotation of the bones. So we don't want to do that. What we want to do is make sure we're scaling it straight ahead. It looks weird, but remember that most of the time this tailbone is just visual, and what matters is the orientation of this bone right here, right? And so remember that we're following this y-axis down the chain, and so when we have it facing forwards like this, it's still following that chain of the foot, right? At least that's what I learned, right? So now we get a nice axis to move around. And from here, I'm just going to place that toe bone sort of separate. And because of that, we can actually move the toe bone in its own little position. Right? I'm going to call this def ankle L, and then def toe L. And this amount of bones is very optimal, very optimized. You don't have to be as optimized for games anymore, but it's just nice to work with such little amount of bones compared to an insane amount of extra bones. And even when we're going to be working soon on the twist bones for certain parts of the body, I'm not going to do an insane amount either. Just it doesn't. It's not always necessary to have so many, as long as you have the general idea, especially for your scope of what you're doing in this program for your games. You don't want to spend forever on little parts of your rig. You just want it all overall working the way you want it or you need it to. But yeah, make sure select, shift select, and then Control P, keep offset. Right, so now it will rotate with it, right? Because your entire foot, you pretty much control all of the foot movement with that around that ankle. So that this is all you need for that, and then the toes are their kind of own thing. And we're not going to be making every single individual toe for this. So that's all you need for the toe, at least in the setup, right? And I think before, actually, yeah, I think now's a good time to start doing our, also I forgot to mention, we're going to be doing some twist bones in a little bit. I'd say after the orientation bones, because we're just going to be duplicating, or after we orientate the bones, just because we're going to be duplicating some of the deformed bones instead of making new ones. But to fix this issue, when you're rotating a wrist and it shrinks like that, we're going to be making twist bones. But for now, we're going to do our bone orientations. So starting now, if we select everything in pose mode, except the root. Actually, you got to make sure the deaf pelvis is parented to the root. So I'm going to do that quickly. If I'm, yeah. So now it's connected to the root. So now the root moves everything. But if I select everything except the root, make sure we're on individual origins and then Rx. So if it goes positive, you see some things are working properly, like it's nice that the spine is working perfectly, but the arm is just straight and we don't want that. So what I'm going to do is, remember, we're just going to follow this whole chain. So Rx is sort of shrinking it down, or flexing. So that's good. Rx, good. Rx, good. Our neck bone as well. It's going positive along the flexing. Take care. Enjoy the gym. What are you hitting today? Think about this. All right. And, oh, here's one actually. Oh, there we go. Sorry. And then make sure I'm rotating along the proper axis. Right? Because if you just rotate along global, it's deceiving. So either you RXX to go local, or I just like to use normal. Right? So the head flexing forward is also correct, all positive. I believe this is where we start to see something that's not right. Rx is not flexing our shoulder properly. To flex our shoulder, think of flexing your shoulder as a shrug. This is sort of the most you're moving your shoulder, the most intense motion your shoulder goes through is flexing them or shrugging them upwards. That's putting them on the most tension and flexing these muscles up here to shrink them a bit, right? Just imagine when you bring it up like that, it's flexing it, it's bringing it all closer together. Right. So in edit mode, we can go back to edit mode and then rotate this. I'd say back to 0. A lot of the time, if you set up the bones properly, it will automatically get the orientations correct. Oh, for this case, 0 is not correct. It's going, oh, it is correct, sorry. It's just you gotta make sure, you can't just rotate it in the viewport because the viewport moves in a clockwise direction. So this is a counterclockwise, so it's negative. But if I do Rx, you can see it's positive along normal X. And same with local X. Right? Set this to 0. And remember that Z can guide us exactly on what rotation to do. So now, but The thing is, you don't do that actually for the arm bones per se, right? For the upper arm, yes, but for the lower arm, no. The lower arm, the elbow, you gotta remember, your arm can't rotate like that. That's impossible. So if you set it to 90, you can see that it's rotating along that elbow in a way that makes sense, right? And you got to imagine that let's see, the actual upper arm here, it's a bit harder to determine it exactly. I'm a little confused, but I'm pretty sure. Let me try to do it 180. Yeah, so let's see. So this is going up, that's flexing. And when you're flexing your arm, it's kind of bringing it towards your body. At least that makes the most sense. And that's what my reference is showing me. And so I'm going to have that positive X flexing direction towards the body. And then this elbow is, as I mentioned, or as I showed earlier. Now I'm just going to figure out transforms. So for the wrist, ideally you want the wrist to move downwards as a flex. That's sort of a flexing. So rotate this to 0. And check, that's negative, so we don't want it 0, we want it 180. So now positive goes down, right? So now we can just follow these bones like so. We did the thumb already earlier, just to show you. Positive X curls in. For the corrective fist bone, you see it's not correct right now. So we gotta set that to 0. No, we gotta set that to 180. See? And so you can see all the Z's are facing down. That's the direction that our flexing is going towards. So all these are set to 90, as you can see, because we copied all the same bones. So I'm just going to select them all. And then set it to -90. Hold Alt, confirm. Because if you don't hold Alt and then confirm, then it's not going to change it for everything. Now if I do back to pose mode, RX. Oh, wait a minute. I made a mistake. See, the X is facing up in this case. Actually, we want our Z to face down. So it seems it's going to be it's going to be 180 instead of 0. See? So 180 for those. And then if I flex, you see it's sort of closing like an actual hand. If I select that entire hand, and then if I do RX, you can see, or yeah. There we go. Sorry, not normal, local. Local will just cause the least problems when you're trying to test this out. So Rx, you can see your hand is curling in a very natural way. And the benefit of doing of orienting the bones first like this is all done at the deformed bone level. And so it saves you so much constraining problems later and manual reorientation of the bones. When you just follow the natural flow of them, it makes it so much easier to manipulate it like this. Right, and for that corrective part of the wrist, you can definitely constrain it to be a little less potent when it rotates in. Like it doesn't have to rotate as much. It could just have a percentage like 20% or 10%. And that's just going to keep correcting. Take care. Correcting it as you close your fist. Right. We're almost there. Following down the foot. Thanks for staying by. I appreciate it. Almost done. And then so, I know. It's all good. Either way, I'm just going to be posting this online for whoever's going to be needing this in the future. So what we're going to do now is do the same thing for the feet, for the legs. I want to make that Z face backwards because, as we remember, positive X will always be towards that Z in this case. So that's flexing, right? Or, wait a second. Actually, for the thighs case, bringing it up is more of a, in our case, that's more of a flexing motion, or that's when we want to do a closing motion, we want it to be forwards, not backwards, like that, right? Imagine you're doing a squat. Squat, your thighs are moving, they're rotating forwards, and that's considered a flexing position. And then for it's pretty simple to tell what that flexing position is, at least for me, what it is for the lower leg. It's going to be, backwards like this. So this is positive X direction. So those together, you get that kind of motion. See? Because when they're opposite, they kind of cancel out. And so it just looks like the leg is being raised up. And that's all being naturally done with the bone orientation. And that saves you so much tedious work later, right? For the foot here, I feel like this rule doesn't apply as well for the foot because of the ankle is going to be like flexing your foot would probably be this direction, but because we don't have access to, or actually, wait, am I mistaken? Wait a minute. I'm wrong. Oopsies. But you can see actually Rx positive will flex it upwards. That's flexing your foot. So I'm going to keep it like that. And then the toe, flexing your toe, think of curling it. So 180. So that's going to be going down like that. That's positive, right? So all together, Rx. When everything curls, you can see it looks like this. And that's all the orientations done properly. And we are very close to being there, to being done through this. But before that, we're going to be talking about the intermediate skeleton. So you're getting a pretty cool little introduction to this. This is an intermediate, as it says in the name, between your def bones and then your control and mechanism bones. And you're thinking, why there's so many different layers of groups of bones already. This is annoying. The reason why is because the intermediate skeleton is, you don't have to make any new bones. All you do is duplicate the existing bones from the deformed skeleton and set the def prefix to the int prefix. And so all this int skeleton will be doing is it will be replacing the def bones, not in their relation to the actual armature or to the actual mesh, but you will only edit the intermediate bones and you will not touch the deformation bones anymore. So you will add a location and rotation constraint to the deformation bones, constraining them to those intermediate bones that are like of the same relation. And then you will never touch the deformation bones again because you don't want to mess up anything that is at that game engine level, which is the deformation bones and the actual mesh. You do not want to touch later on, because if you mess something up, it's going to mess up your entire animation and your entire model within the engine. So we're trying to stay away from touching the deformation bones. Through the intermediate bones, and I didn't mention here, when we export our armature out of Blender, everything will be deleted except for our deformation bones. So this keeps everything nice and separated and allows us to make sure we don't mess anything up later. And it's game industry practice, so I don't make the rules, you don't have to follow it. But this is good practice, and I'm sure that if you follow this practice, you will be rewarded greatly for your good work habits. And as I mentioned, all future links through constraints or otherwise are going to be hooked up to the intermediate bones, not the deform bones. I know it's annoying to have so many layers of bones, but this saves headaches and issues later. And we can leverage the strength of group bone or bone groups to hide the different layers that we are not wanting to see. Because you see there's a lot of bones here overlapping, and that's really tedious to navigate. And as I mentioned before, we have the bone naming shortcuts. Control F2 allows you to batch rename everything all at once. And we're gonna be using that in a second. And then bone collections to separate those different bones that we're making, right? And so for that, we're going to go in here and we're not going to mirror it over yet because we don't want to have to do these steps that we're going to do double the amount of time. So we're going to select every bone in edit mode, except the root bone, and then before that we haven't even made a bone collection for the deformation bone, so I'm just going to do that. I'm going to make def assign these bones I'm selecting right now. So everything is in that def group except that root, right? I'm just going to call this root. So remove everything and then just add the root bone to root. Just for now. So I'm going to select everything in def and I'm going to Shift D and then just right click to leave it where it was in space. And so now we have 30 more bones generated, and you'll notice that every single bone we'll have the .001 because remember we called the variations dot or spine A, spine B, spine C, or finger A, finger B, finger C, because you'll see in a second this is going to help us tremendously with batch renaming. So if before we even deselect it, we want to make sure we change these names ASAP. So I'm going to control F2, find everything that says def, replace it with int. And we have the intermediate bones now. And then because we named ABC instead of numbers, we can easily find everything with .001, replace it with nothing. And so these two groups of bones are the exact same names, except the int and def prefix is different. And that's very, very, very important. And I'm gonna create a new group. I'm gonna select def, remove, so I still have the int bones selected. I'm gonna remove them from int, or remove the int bones from the def group. This new group is called int. Select the int group, assign it. And so now you'll see that if I select, it's gonna just select everything in int group. If I click on def and I select, it's gonna select everything in the def group. And it's hard to figure out what's going on because everything is overlapping like this. And to fix that, what we can do is we can use Blender's bone visual indicators to sort of change the size of our bones. So if I select every single def bone, they're there, but you can't see them, right? However, if I go into bone, also before we even move it forward, we gotta make sure we click on the intermediate bones, or because we made a group now, we can just go to the group and select all. We're gonna go into this menu here and then Alt and then click deform to remove the deform on those intermediate bones. You can see, oh dear, wait, it did not remove it for, oh wait, it did. Did it? Oh, oops, sorry. I need to not hide it like that. I need to hide the def bones like this. You can see because I Alt clicked deform here on one bone, it deselected it for everything, right? So just once again, see if I select two bones, Alt deform and click deform, it will check it on for both. If I select both, Alt click deform, it will remove it for both. It's very important because it makes sure that those bones aren't auto-weighted. If you're doing auto-weight painting, it won't automatically assign them. It'll just ignore them. But you might want to do regular weight painting for this. And actually, I did miss a step. My mistake. I forgot to talk about the twist bones. So we can quickly get those working right now, just very simply. So twist bones are preventing that sort of wrist. When you move your wrist, it's not just rotating at the wrist point, it's also rotating across the entire arm. And so if we add a bone, at least one bone in the middle, we can rotate this bone proportionally between these two bones. We can rotate it maybe 50% or 40% or 60%, whatever amount works for us, to smoothen out that transition between these two pivot points versus a very sharp one right here. So it is a little late into the process, my bad, I forgot to do this earlier. But we can quickly get that in. If I go back to the def bones, we're gonna want this bone we're gonna be making to be at the, like, parented to this forearm bone. So I'm just gonna click Shift D and X, and so just bring it as close as I can to the middle, right? And just sort of try my best to orient it exactly where it needs to go, like this. I'm not going to make it absolutely precise right now, just wanted to show the example here. Around the middle, and then if I cursor to selection and then selection the cursor, snap it there. Right? But ideally you'd want this bone, this part of the bone here in the center of these two, and its axis also following exactly the same path, right? Make sure I'm gonna select this bone and then select the forearm, Control P, keep offset. Now it's parented to this bone. So it follows that, but it's not going to be parented to anything else, or it's not going to have a child object. It's just its own little thing in this chain. It's its own little thing. Now I'm going to, you'll see in here under def form, there's wrist and lower forearm or lower arm. I'm going to name this to lower arm twist. So that's our twist bone. And so you can imagine that when I rotate this arm here, you can rotate this. You don't have to do it manually, but you can add a constraint to follow the rotation of this arm, or of the wrist here, to rotate with it. And so because it's in the center, it's going to blend between these two, right? Create a smooth transition at that wrist point. Right, so I'm gonna do that there, and then I'm gonna just do, I'm gonna do one at the leg as well. Mind you, you could have one also at the upper arm. Actually, I'm gonna do all of the ones that are needed or that are recommended. And if you want this to be absolutely precise, because I just kind of eyeballed it, what you can do is duplicate this and then subdivide it, right? And you get a perfect halving of the bone. So I can delete one of those and just kind of move it. And you see here it's lined up exactly halfway, right? So that's a better approach than what I did over here, but I'm just gonna leave that one for now. Gotta keep moving forward. Parent, keep offset. Remember now it's its own little thing. So in here, you can see the upper arm here, there is the lower arm, and then the upper arm twist. Upper arm twist. Now for the legs here, I'm gonna edit mode, duplicate, subdivide, and then I will delete the first one in the chain of each. Delete that first one and then delete this first one. You could have the entire, like this entire chain of 4 bones, like 1, 2, 3, 4. But to be once again, as concise as possible, I'm just going to do the one closer to the middle, right? Because if you have if you have both of the twist bones on the same, or if you have a twist bone on the same point as this point, it's a little less necessary, but it's still important for some use cases. I'm just going to do it like this. Just show you it exists. Lower leg twist. And then upper leg twist. And remember, you gotta reparent it. So select this bone, select main bone here, Control P. Check, it's there. Select, keep offset. See? So in lower leg here, we have ankle and lower leg twist. And those are the twist bones. Sorry, I missed them earlier, but now we have them. And so because of that, I'm actually just going to select these intermediate bones. I don't delete them, just because I want to make sure I redo the duplication with the new twist bones added. And see, now I can select them all, Shift D, and then remember I can Control F2, find def, replace it with int. All int now. Then find everything with .001, replace it with nothing. Oh, not zero, nothing. So there. And at that point, I can now remove it from def collection and then assign it to int collection. And so now we can see that when I turn on def, it's def bones. When I turn on int, it's the int bones. Beautiful. And then remember, at this point, I can select all these bones and then Alt, make sure that int bones you're selecting, and then Alt, uncheck deform. Now they're all not deforming. Because remember, we're just constraining the deformation bones to the intermediate bones. Now at this point, you'll notice that it's hard to visually see each bone separately. So to fix that, we're going to make the def bones. We're going to change both of them, but we're going to start with the def bones. Go into bendy bones, or sorry, go into the bone properties, viewport display, display as bbone. Make sure also Alt select bbone. So now they all turn into boxes like this. It's very chunky right now, so I'm just going to go to the bendy bones tab here. I'm going to hold left click, scroll down, or move my mouse down so it's selecting both. Hold Alt, and then scroll. And I can also do Shift to make it more precise. See, I'm going to make the deformation bones very, very thin, like this. So I like bendy bones because you can change the display much quicker and much nicer. Right, so in bone properties, you go down to viewport display. You see display as, change it to bbone. Make sure you hold Alt and click it. Yeah, you select all the bones here. Display as bbone, and then Alt click it. And then from there, I go back to the intermediate bones. I select them all. Same thing. Go scroll down in the bone properties. I'm just going to close all these tabs. There we go. So viewport display. Make sure I'm selecting those new groups because it was thinking I was still selecting the other groups. I'm just going to make sure I have at least one bone actually selected. Alt display as B-bone while holding Alt. And then from here, I can then go back to that bendy bone tab, display size, hold Alt, scale it down a little bit, not as much as before. So about there. Now you'll notice if I turn back the def bones on, you can see the def bones are inside. So the def bones are right here. I don't know why that happened. I don't need to draw. It's fine. Def bones are in here. Intermediate bones are here. And at this point, what you would have to do to make sure that when you pose the intermediate bones, which are the ones you interact with, that these other bones in here follow, is you have to, it's very annoying, you have to control, so select the bone you want to constrain first, and then the second bone that it will constrain to. Control Shift C. This is a way to quickly add constraints. Copy location. Control Shift C. Copy rotation. Oh, sorry, I did it in the wrong order. So you select the bone you want to constrain it to, and then the target bone that will have the constraint. So first select the bone that you want to constrain it to, and then second, you would select the bone that you want to add the constraint to. So that's intermediate bone first, def bone second. And Control Shift C, copy location, copy rotation. Now you can see that it follows suit. It won't follow scale, but it only follows rotation and location. And what's the problem you see with doing this? Do you see a problem? The constraints are fine. The constraints are perfect. But like watch, I'm gonna have to now select another bone and select another bone. And then Control Shift C. Control Shift C for every single bone in its entire rig. There's no automated way to do it in Blender natively, which is ridiculous. Shift R to add a rotation constraint.
No, like to copy, like what constraint is it?
Oh yeah. It's Shift R, or is it Shift R or Control R?
Shift R.
Oh yeah. The problem is you got to do that still. You got to select every single part of the mesh, add it to it, add it to it, add it to it, and that's really tedious. And we don't want to do that. So Blender does not have by default a way to do this automatically, and that sucks a lot. But to combat this, I sort of constructed as optimized or as simple as possible this Python script to batch constrain, do exactly what we're doing, but do it automatically. So I'm asking you essentially to constrain every single def bone to its int counterpart, which is tedious manual labor. So I created a small script here that batch constrains all the def bones to the int bones, location and rotations automatically. As long as the naming is exact, as I showcase in this tutorial, then you should have no problems with it. And also you need to select the def and int bones together in pose mode, not in edit mode, or else it won't work. So if you go, so have you made the rig up to this point so far?
Yeah.
Okay, perfect. So you can try this out then. So if you go to week 6, you'll see there is a constrain to defint.py script, and it just shows as like a text file
Yeah.
in here, or like like this. You're gonna download it. Oh, they just give me why do you give me an access denied?
Like
There we go.
download it?
Yeah.
Save it?
No, it was just because I think I had Canvas open for so long, it lost its identification of me or something. But now I have this Python script here. What I do is I go into Blender, go to the very top here, scroll if you can't see it, scripting. I already had this script in here, so I'm just gonna delete these scripts. Start fresh, open. If I go to downloads, constrain def to int.py, open text, it just pops in right there. So the way I approach this, setting this up, there is no actual, it doesn't create a operator, like a option in here to click instead, or it doesn't make a panel, a 3D panel. What I made was very, very bare bones. It just, you have to click play here to do the function in the scene itself. So there's no way to do this without executing it directly in the script. At least the way I set it up, because you have to create all of the register it as a operator and everything. So I didn't want to do that just because for the sake of this, it wasn't worth just bashing my head against the wall for it. So to use this, what we're gonna do is we're gonna select the def group collection, click select, and then the int group select. So now they're both selected in pose mode. And make sure the root bone is not a part of those collections, so it's unselected. Is it unselected? Okay. So you have all the def bones, all the int bones. And so if you go into the script and simply click that play button, if you go back, you'll see all the def bones are green.
Yeah.
Do you see that? You can see all those constraints, all those location and rotation constraints are added to the def bones only.
Mine is in the opposite.
Is it the opposite for you?
Yeah. I think you gotta select it differently. What you gotta select? Is it in first and then def, or is it?
The order doesn't matter. It shouldn't matter. You show me?
Yeah. Um,
Your int bones are on the inside, I believe. Click on that one. If you go to the hierarchy, and then show active. Yeah, so your int bones are in the middle. So your def bones are the big ones.
Yeah.
So it did it correctly. So if you click R and then rotate it, see the int bone is constraining, or the def bones are constrained to the int bones. So it's just you made the def bones bigger in your case. Yeah. So it worked properly. If you look in the hierarchy, it shows the constraints only on the def bones for you, right?
Yeah.
Like this.
Yeah.
Okay, that's good. I was like weird. I was like, oh no, I gotta troubleshoot it. So that is how you set up your armature, your deform armature with the intermediate bones. Because now we would ideally have the def bones weight painted to the mesh itself, and then the in bones are the only ones that are actually visible. So what we can do quickly is just, we can mirror this over. And so if I go pose, or is it pose mode? No, it's edit mode, yeah. Select every bone except the root, of course. Symmetrize. It's a bit weird because I believe the direction it sets these bones to is wrong, if I'm not mistaken. Let me see. RX. Oh no, it's correct. So after that mirroring, you can see now we have everything on the opposite side. Let's do it once again just to make sure I did it properly. So symmetrize. From positive x, because this is, if we look here, positive x to negative x. You see? From positive x to negative x. So we select that there so that when we symmetrize, it's accurately changing the orientations. And so at this point, we can just hide the intermediate bones for now. Now we can select, so to parent, to parent the bones to the mesh, we select the bones first and then select, or the mesh and then the bones. In this case, we're going to do auto weight painting, but it's going to look pretty bad, I think, because specifically around the fingers, it's going to look pretty bad, but we'll do it anyway. We'll do Control P, armature deform with automatic weights. Boom. And we can visualize this if I change my viewport back to the solid view. Select the bones, then select the mesh, Control Tab, weight paint. We can see, actually I want to make sure also the bones are in front, so bone X-ray. We got autos. Let's see how the fingers did. It's a bit, it's not bad.
Yeah, it's not bad.
That's pretty good.
Yeah.
Wow.
Usually for like my models, I would have to like go in and like weight it all.
Yeah, I'm genuinely impressed. We'll see how this all moves in a second. I feel like the leg is gonna have issues here, but we'll see. Let's see.
I feel like the legs
Oh yeah. And see, we can't rotate it right now because it's constrained, right?
Yeah.
So if we go back to object mode, we are not touching the deformation bones. So those are hidden now forever. We only interact with these intermediate bones. And you can see if I go to pose mode, they are, so the weights aren't perfect, but we can see that the constraints are working properly. The scaling, we don't obviously have a scaling. The scaling, what's it? Constraints, and that's okay. We just have the location and rotation constraints. And you can see here, if I rotate this, nice. And we can even test out our twist bones now. So if I rotate my wrist, so let's say we rotate it upwards like this, along, so we can do it along, let's say Y, 90, negative 90, like this. You can see that ugly part of the wrist there.
Yeah.
But if I rotate this part of the arm. It's a little scuffed because the weight paints are not perfect, but ideally you'd have a smooth weight painting across. Rotate that about 45 degrees, more or less. You can see that it's trying to follow that twisting path, right, as well as it can. Let me see if I can make this a little better. See, it only affects the weights. It doesn't affect any of the bones. So if I go into, this is when I can go back to the depth here. And if I select depth first and then the mesh, I can go in here and I can sort of paint this more richly. Oh, but I gotta actually, as we learned before, I gotta make sure to change my brush, change the fall off to projected so that it cuts all the way through, right? So now it's cutting all the way through like this. I want to make sure my blur brush is projected as well. I like to have projected blur brushes so it cuts all the way through. Did you call Alt select the bone you wanted to weight paint? Before you even go into weight paint mode, did you make sure to select the bone first? Like select the deformation bones first, and then shift select the armature? And then weight paint. Really? Huh. It's a little annoying. Let me see. Are you selecting? Oh, you're selecting the intermediate bones. Oh. Yeah. So that remember, this is what's good about it. You can just hide the bones you don't want to remember and just select them. So you select the deep that first. Yeah. So ideally you want to make that one really small and then the one really big. So you can select select all. So yeah, you select all the deep detachments right now. And then you go to bone and then so scroll down. Or not scroll down, sorry. But click on new first. You're gonna select and drag down so it selects both at the same time, and then hold Alt and drag. You can hold Shift as well to make the same person. Oh. So look at this one. If you go back to the intermediate ones, you can make them bigger. I forgot to turn on auto normalize before I started weight painting, but that's very important, of course. That's the thing with I believe that auto weights doesn't normalize properly. At least I think. All right, let's test this out. So I'm going to actually just reset the posing of my intermediate bones. Pose, clear, all. And then I'm going to add a little constraint on here. Because remember, now that we're constraining only the intermediate bones, we won't have any sort of issues on our deform level. They're just copying from this intermediate rig, and the intermediate rig we can add our own little constraints to if we want. I'm going to add a copy rotation, and the target is going to be this armature, and the target will be the intermediate wrist bone. And I'll set the influence to 0.75 maybe. And it's going to oops, not that. So now, which one would it be?
So where is the copy rotation?
So I'm adding the copy rotation to that intermediate wrist, or sorry, not intermediate wrist, to the intermediate lower arm twist. So remember that second one I created? So adding the constraint to that, and it's constrained to the intermediate wrist. So whenever I rotate the wrist, the axis isn't set yet. Look, it's not set properly. I just want to constrain the, is it X? Which axis would it be? It'd probably be the Y. Let's see. Rotate Y. After original makes sense, I think. Oh, but it's going the opposite way. Oh, we got to invert it. Invert. It's not perfect setup, but it's getting there. You can see now that, oh, I love it. It's actually so satisfying to see. Look, now when I rotate the wrist, it twists the forearm as you would expect it to be. Right? And that's only with one bone. So it's not absolutely perfect. And you can see I could even give it a 0.5 influence. And so now, oh, it kind of has a bit of a pop. All right, so I came up with a little temporary solution to address this problem, and it was simply adding a limit rotation to the wrist itself so that you can't rotate it past 135 degrees. You can do more or less, but that's what I chose because actually, realistically, you can't move your wrist beyond that point. Beyond that point, you know. So the wrist will not allow you to move past certain points. And if you wanted to keep rotating your hand upwards, then oops, that would be involving the actual elbow area moving as well, right? So when you actually want to rotate your arm fully like that, it's going to involve several parts working together. But you see there's still a bit of snapping, which is really annoying, but that's just how it is, unfortunately. At least with this setup. You see, it's working better now. And yeah, that's what I got for that. Thank you so much.